Okay, in this video we're just going to go through this example problem. We're going to start off, of course, with writing our junction rule. So let's look at the way we think the current's going to be moving through this circuit. So I have this battery here, and I feel like that's going to be pushing the charges through the wire this way. And then the current has two options. It will either be pushed down this wire or continue straight into that wire. So let's look at what else is happening in the circuit. We have this other battery right here, and there's nothing to push the charges in this branch right here. So I imagine the charges are going to be pushed this way through that wire due to that battery. So we have charge being pushed this way, charge being pushed that way. Those are going to combine and come down in that center branch. Now that's just what I'm kind of making up. I'm not 100%. So I have current moving this way, current moving that way, and then adding in that branch. Now once it comes out of that branch right here, this junction, it's going to split so that it keeps moving through those loops. All right, and that's the direction of the currents. I'm going to call this one just I3 because it matches up with the 3 ohm resistor. I2 and I4. So looking at how my currents are moving through the circuit, I know that this one up here is still I2. Everything in that right branch here is the same value of the current. Everywhere over here has the same value of that current, so that's I3. So I know that I2 and I3 are going to come together to equal I4. So as long as you pick your direction of the current flow, you can completely guess, have all three of them in the wrong direction, and you can still get the correct answer at the end. Just make sure that you reason out your junction rule the appropriate way. All right, so there's our junction rule. We need to handle our loop rule now. Remember, the loop rule is the sum of all the potentials around the circuit. So if I pick a point here, and well, first let's just pick our two loops. I'm going to use the two outer edges with the battery. So I'm going to move my loop in the direction of the currents. It makes it easier because you always subtract across the resistor and add across the battery if you're moving in the direction of the current. So I'm going to use those two loops right there. Change this color. Make that one pink. All right. I'm going to move through the left-hand loop, and I'm going to start here. All right. So as I move through this wire this way, I'm going to gain a potential of 12. Then I don't hit anything until I hit resistor 4. So I'm going to subtract the I times R, right? So the R is 4 ohms, and the current is I4. And then I hit the 3 ohm resistor right here. So I'm going to subtract my 3 ohms times the current through that resistor. That has to equal 0. All right, so I got two of my equations done. Let's handle the right-hand loop. I'm going to start here, move up across the battery, so I'm going to gain 5 volts. Move through, hit the 4 ohm resistor, so minus 4 times I4. Then I hit the 2 ohm resistor, minus 2 times I2. And then I end back where I started, right? So plus 5 minus 4I minus 2I. And that equals 0. So those are my three equations. Now I'm going to find the value that is the same in each of the equations here. And I4 is what is contained in all of them. So what I want to do is I want to solve for the other two in my loop rule equations. So I want to solve for I3 in this equation and I2 in this equation. So I'm going to take this equation here and I'm going to manipulate that for I3. Right? So I'm going to bring this one down in this area. Alright, so I'm going to have 12 minus 4I4 equals 3I3. Then I divide both sides by 3. So 12 divided by 3 is 4. That's minus 4/3 I4, and that equals I3. Okay. I'm going to do the same thing, but for I2 for this equation. So I5 minus 4I4 equals 2 I2. Divide both sides by 2. 5/2 minus 2I4 equals I2. Now what I have is values to plug back into my junction rule. So I'm going to take this and put it there. And I'm going to take this and put it there. Now what I'll end up with is an L4 on that side. I'm not an L4, an I4. An I4 in that term and an I4 in that term. So that the first current that I'm going to solve for is the current through resistor 4. Okay, here's that substitution. Now I just have to combine like terms. So I'm going to move all the I4s to one side and the constants to the other side. So if I add the 2 I4 over to this side, I'll get 3 I4, and I'm going to add the 4/3 I4 over here as well, and that leaves the 5/2 plus the 4, where 4 is 8/2, 8 plus 5 is 13/2. Alright, so we just got to combine what's over here. 3 times 3 is 9, so 3 is 9/3. 9 plus 4 is 13/3. I4 equals 13/2. 13s will cancel out, so you're left with 1/3 I4 equals 1/2. Just move that 3 to the other side. You get I4 is equal to 3/2 or 1.5 amps. Alright, so there's our first current. The next thing to do is solve for one of the other ones. Notice that in the I2 equation, the only thing we don't know on the left-hand side is that I4. And in the I3 equation, the only thing we don't have is the I4. So if you plug that 1.5 into either of those two equations, you'll get I3 or I2, depending on which one you pick. So I'm going to pick I2. All right, I already rewrote the equation for I2, plugged in my 1.5. So I2 is going to be 5/2 minus 3. And that equals 5/2 minus 6/2, which gives us negative 1/2. Oh, interesting, huh? What does the negative sign mean? All that means is that we chose the wrong direction. So instead of I2 moving this way through the circuit, I2 is moving this way through the circuit. Doesn't make us wrong, all right? We really don't have a great understanding that you can mentally pick the direction of the current every single time we see a circuit. So this is 100% acceptable, all right? The choosing of the direction of the current is just a basically a mathematical setup, right? Okay, so we have two of the currents. We have one more equation that we didn't use, which is our current junction rule. So if we add or plug in the 1.5 and the 0.5 into our junction rule equation, we should be able to easily solve for that last current. Okay, so I4 is equal to I2 plus I3. We know that I4 is 1.5 amps. We know that I2 is negative 0.5 amps. And we don't know I3. So if we add the 5 amps over to the other side, we'll get 2 amps. And I3 is equal to 2 amps. So I3 is 2 amps, I4 is 1.5, and I2 is negative 0.5. And that would be the entire problem. All right, so here you can see that I built the circuit. I'm going to make sure that okay, so that battery's 12, this battery's 5. Make this resistor 4 ohms. This was the 2 ohm. And this one was the 3 ohm. All right, now that looks like a real circuit with batteries and resistors. If we change it to the schematics, you can see it looks like the problem, using conventional current for the direction of the positive flow. And you can see here the direction that the current is flowing, and we had that incorrect, right? So if we wanted to figure out what the current was in each of these, I'd have to insert those ammeters inside of the wires. So let me do that. Okay, and you can see that the ammeters are measuring the same current that we solved for in our problem. Of course, this one's not negative over here, the 0.5, because it's moving in the correct direction. All right, so the ammeters won't give you a negative current as long as it's connected appropriately. So you can see that these problems can take a little bit of time. Once you learn the procedures, it does make it go a little bit faster. So these are the things that you kind of want to make sure that you know. So you're going to pick the direction of the current flow and write out your junction rule. That's number one, first thing we did. You're going to pick 2 loops and write up the sum of those potentials, set it equal to 0. And this just tells you, again, if you're in the direction of the current, it subtracts. If you're in the opposite direction, it'll add. Okay, and same thing. It's similar for batteries. If you go in the direction of current through the battery towards the positive, you'll add it. If you go towards the negative, it'll subtract. And once you get all 3 of those equations written down, you find what the common element is and solve for the other one. Right, so in our problem, I4 was in every equation, but we solved for the I2 and I3. Once you solve for each of the other 2 equations for the other 2 currents, you'll plug those into the junction rule and solve for that first current. You'll plug that current back into the loop rule equations to solve for the other 2. All right, so make sure you write that down, follow this as you work on the problems, and once you almost memorize the procedure, you'll get a lot quicker at solving these problems.